Okay, let's get started. Welcome, everybody. Thank you very much for being here to this episode of the ANRA Huddle. And today we're discussing one of the most exciting and interesting topics in the industry to get today, which is urban air mobility or UAM. I'm Miriam McNabb, editor at commercial drone news site Dronelife, and I'm honored to be moderating this panel of thought leaders in the industry. These three gentlemen have worked together on a wide variety of UAM issues, and I'm really looking forward to hearing them as they approach the topic from a variety of different perspectives. Amit Ganju is founder and CEO of ANRA Technologies, drone operations and UAS traffic management UTM platform provider. Robert Garrity is the Senior External Affairs Officer at the Cesar Joint Undertaking in Europe, supporting Europe's central research program into the future of European air traffic management. And Parimal Koperdecker, or PK, serves as the Director of NASA Aeronautics Research Institute and NASA's Senior Technologist for Air Transportation Systems. Gentlemen, welcome and thank you all for being here. Before we get started, I have just one thing to mention to our audience. Please submit questions during the last 15 minutes of the session by using the Q&A box at the bottom of your screen that will appear during the last 15 minutes of the session. We'll try to get to as many of those as possible. Let's get started with one of the questions that's kind of central to the discussion on UAM. I admit I am a sucker for a beautiful rendering. I publish pieces about passenger eVTOLs all the time, one test flight, one new design, one new agreement, beautiful aircraft. I sit in them at the shows. I play around with the simulators. But there are a lot of other pieces that have to go into urban air mobility operations beyond aircraft. So, Robin, you started your career in air traffic control. You've literally written the book on tons of these policies that go into UTM and drone integration. You're leading the discussion, Europe, throughout the world. What else do we need besides cool aircraft to actually make urban air mobility a reality?
Well, thank you for the question, Miriam. I think we've all seen, as you say, all these amazing new designs of aircraft, either computer simulations or real vehicles flying, and they are certainly extremely exciting. I think we need to contain our enthusiasm just a little bit when it comes to trying to make sensible and safe operations, and that these are aerial operations that are going to carry people, amongst other things, and therefore they need to be safe. They need to be efficient, and they're not going to redraw the whole picture. They're going to have to integrate with a great deal of established aviation users as well. So that means that any system that we come up with to operate them will need to take into full consideration all classes of aviation user, from your airliners right the way down to sports aviation and everything in between, including military. And many have very different flight characteristics, operate in full range of airspace types and over the city and in places where we're not used to seeing aircraft. So lower down, over built up areas, near airports, all the places typically you don't want airplanes to fly. So this is a whole new ecosystem that we're going to need to create with new regulations, new technologies, new supporting technologies, and everyone's going to have to play nice and work out that everyone has a piece to play in this, and it's going to be complicated and it's not going to happen overnight.
Amit, I've heard you talk about this before, sort of the crawl, walk, run approach. And as Robin says, you've got all of these different components that have to go into it. So what's crawl look like? What's walk? How does that work? What does that look like?
So that's a great question, Miriam, and I think it depends. That's a typical engineer's answer, but it actually does depend, because we always talk about three circles. There's technology, there's standards, and there's regulation. All have to kind of get married together for this thing to move forward. And depending on the regulatory framework of a particular jurisdiction, certain things may happen, whereas in another regulatory framework, something else may happen. So if we were to look in terms of broad stroke at a very high level, in the crawl phase, I would lot of these aircraft initially, these eVTOL aircraft, many of them are going to be optionally piloted initially. Some of them some vendors are looking to go completely autonomous day one, but most of them are going to be optionally piloted, which means there will be some, in the near term, we'll try to leverage some of the existing mechanisms for air traffic management as we integrate these new entrants into the airspace. Whereas there's corridors where traffic gets managed by airspace use space service providers or PSUs or equivalents, and then there's an integration aspect into the legacy air traffic control, ingress, egress, and some of the legacy voice comms, which will now need to be digitized. So I think we'll see an incremental approach where there's the combination using some of the legacy mechanics and some new ones till we gradually start transitioning to a fully integrated digitized system.
Okay, so I'm hearing sort of pieces. It's going to take a long time to get all that together, but PK, from your position at NASA, you are working very, very closely with the US government, with the FAA, with these stakeholders. And I don't know what it is about the Olympics, but the last time I heard Billy Nolan speak, he said, we're going to have UAM in LA during the 2028 Olympics. I just wrote a piece today. Volocopter now says that they've made an agreement that Paris is going to be the first European city to integrate UAM eVTOL services during the 2024 Olympics. So I don't know what it is about the Olympics. Is that going to happen by 2028? And are those just kind of demonstration services that will go away with temporary stadiums, after the Olympics?
Yeah, I think that's a great question. There is definitely a strong interest in showing that these operations and vehicles is reality and they will benefit the society at large. Whether Olympics or not, there are a number of use cases. I think what's really critical is how do we make sure that these are beneficial for society. So, from wildland firefighting to search and rescue to cargo operations to carrying passengers where it has never touched aviation, that's the real promise. And the long term promise is if you're actually able to use this electric vertical takeoff and landing vehicles, we all don't have to travel to the central business district or stay close or live close to the highways so that we have rapid access to transportation to get you to the offices where the road takes you. These vehicles can take you 360 degrees in any direction, 50, 100, 200 miles range as the batteries improve. And if that happens, you can see the society can be completely transformed. And that's the future that's really exciting. You can see that people will live away, businesses will be redistributed, and it could be better integrated green and office or living spaces away from just the central business district because that's where the roads take you today. So it's all dependent on transportation. But if we can unleash the transportation, then it can change and transform the society. That's what I'm really excited about. So yeah, the Olympics type of demonstrations are useful to gain public confidence that this thing may be real. But really, we need to have entire transportation system, as Robin was saying and Amit was saying, that includes the aircraft and the safety of the operation and the flight, airspace system, infrastructure that allows us to collectively unleash the past true value of aviation for societal benefit.
Excuse me. Let me take that and ask all three of you to kind of play on that a little bit. The four of us have actually been in this industry for quite a while. So I can remember during Hurricane Harvey, I think it was back in Houston, where commercial drones really got their time in the spotlight as disaster response tools. That was sort of the first time that they were flying over homes, helping with reconstruction, rescue efforts at first, and then insurance evaluations afterwards. And I view that as a real turning point for commercial drones. So do you think that if we could get into some of these more niche emergency response, wildfire, EMS, organ transplant, transportation, that kind of thing, that would be helpful. As you say, of course, the dream is to be able to go in any direction out. But for right now, would that be a good way to get started? What do you think?
I can. Yeah, Robin, go ahead.
Sorry, thank you, Amit. Yeah, and it says our program has which is the European research program and demonstration program into these new entrants, has had a series of projects which have very much involved the society. So, for example, we had a project, Sapphire Med, which looked in detail at the movement of medical samples between helicopters in the city of Antwerp. And this is now done routinely thanks to the program. It's operating. EASA has approved it, so we're seeing the benefits to society right now. But there is only a limited amount of benefit you can get from focusing on these individual tasks. Obviously, it's a use case. You have to try, you have to practice, you have to demonstrate, slowly build. This is the crawl, walk, run. We have to start somewhere and get little examples, find things that work, and then learn from that, put it back into the big picture, and carry on evolving. But many of the things that you mentioned there, like the hurricane disaster relief, fire, this kind of thing, typically you rope off the airspace, protect it from all other airspace users, and then you are in control. You can do whatever you like. That's not good enough for routine operations that we're envisaging. What we're trying to do is integrate, and that makes it a great deal more complicated. When you have, yes, you have your little drones, and then you have your eVTOLs, and you have helicopters, and you have private pilots, and you have airliners. Getting these to work together safely and seamlessly is a great challenge. So I particularly like the crawl, walk, run analogy, and we need to follow it. Yes, it's nice to have a vision and distance, and we all like visions and glossy documents, but we need to keep our feet firmly on the ground. Do something, try it, see what works, what doesn't work, get the benefits about what we've got now, and then apply it, modify it as more users appear on the scene, more use cases appear, then we can learn, apply it, and grow.
Yeah. You're on mute. Miriam, you're on mute.
Thank you very much. How does anybody make money while they're waiting for that to happen? Who's funding the development of these systems? Because if you're going really, really slow and you're only doing one, I mean, how can any of these companies sort of fund their development, or should that be a government responsibility?
TK, you want to take a stab at it first, or you want me to go?
You go first, and I can definitely add.
It's an easy question. Come on, guys.
Yeah, definitely.
So that's the $1 million question. So I think you have to look at the ecosystem play here. It's not just the aircraft and stuff. So there are different stakeholders in this mix: the infrastructure providers, the digital infrastructure, the physical infrastructure, and the aircraft, and the operator. So there are technically 4 or 5 stakeholders. Each of them have to figure out how to make money. So it's not just someone sold an aircraft, like Airbus, Boeing sells an aircraft, but they're not the ones that operate it and make money. So you have to figure out how each one makes money. So if I build on the example you use, and Robin used of Sapphire Med, the next phase of that is Sapphire Ready. We are actually part of Sapphire Ready project. So that is actually solving a near to midterm need. So anytime there's a humanitarian aspect of things, that will always, I think those will be all the early use cases. And I think that's where the initial money will be made. It's not going to be these flights from downtown to a suburb kind of thing. That'll happen eventually, but I don't think that'll be early. So early adoption will be cargo. It may not be the large scale cargo, but not the real small packages as well, somewhere in the middle. That's what I see. And how people make money, I think there are ways to monetize that. Initially, I believe in certain cases, depending on which geography, where it is going to be deployed, there may be need for some investment in the infrastructure side. So something that needs to be funded either by the industry or public-private partnerships. Like industry venture capitals have been pumping money into this business for a decade, going on a decade, and they're still looking for returns. But I think there'll be a combination of public-private partnership where the states and governments and communities will have to put in some money and then subsidize some operations till they, in my view, till they get some scale, and then it's become the sustainable revenue model. I'd love to hear what PK thinks about it. So over to you, PK.
Well, I think it all depends on the minimum viable products and strategy. Money making is one part of it, but benefit to society is another. For example, wildland firefighting, autonomous drones could have a significant play in helping with that. So, if you look at 2020, the top 5 wildfires costed over $1.7 billion in the United States, and they all lasted more than a month. Some of them lasted for more than 3 months. And if you see how the firefighting works, aerial suppression particularly, right now, there's a aircraft flying, there is an Airbus sitting and watching outside the window and managing the traffic of fixed wing and rotary wing helicopters who are dispatching water and retardant. And as a result, when the visibility goes down or smokestacks show up, they stop the operation. When they stop the operation, they can't continue to fight from aerial means. And we want to expand that paradigm from 6 to 8 hours a day to 24 hours a day. And autonomous aviation can really transform that. So I think there are reasons to do these kind of operations beyond just making money as the sole purpose at the beginning. And in the beginning stages of any emerging industry, they may or may not be profitable, but it's the long run. When mature state or when it starts to pick up, that's when the revenue and profit and loss things come in picture. Amazon didn't make money for a long time, but now it's one of the most successful companies. So I think we have to look past just the initial stages, the crawl and walk stages, before we start to think about money. I think in the long run, these things will get sorted out. If they are beneficial to public, they are beneficial to businesses, it will automatically figure it out itself. So I worry less about focusing on making money part, but making sure that there are solid beneficial use cases as well as the entire ecosystem, like you all are saying, in terms of aircraft, airspace and infrastructure is ready to be able to accommodate them in a safe manner.
So, Robin, one thing that I know I have heard you say is that it's one thing to get one aircraft up and running. You can always get one aircraft up and running, but can you get 1,000 aircraft operating together safely? So how do we get from 1 to 1,000? How do we ramp up those demonstrations? How do we get so that when you're in a firefighting situation, you can say, okay, over this particular fire, we are going to have helicopters, unmanned eVTOL, small drones, and so forth, all operating together. How do we get there?
I guess the answer is really complicated, and elements of what all the speakers have said today will come into play. But I think we need to have an agreed operational concept, how it all fits together. And I don't mean that a document. I mean, really, we've got to buy into this and that all elements of the aviation world with a part to play. Now, with the investment angle on this, there's always someone willing to invest in an aeroplane. But if someone wants to invest in a CNS infrastructure for drones, that's kind of different, because without drones flying, why would you invest in the infrastructure? But you can't have them flying unless there is an infrastructure. So it's a real chicken and the egg situation. In Europe, what we're finding is that by having a drone strategy for Europe, we're encouraging European businesses to try and play into this across the full spectrum of the stakeholder groups that allows that initial investment to encourage industries to come and play. And we're finding that now, that with our latest set of projects, it's deliberately there to provide some support to those states that are the early movers. So one of our projects, Birdie, is looking, by the end of its 2-year project, it will have a nationwide commercially viable new space service deployed with customers, because they're part of this growth program. So, You need to start small. You need to identify exactly what it is you want to do, bring the right people in, invest where possible, if possible, at a state level. That's not always possible, I fully recognize, and to encourage businesses to be able to make use of what the seed that you've put in there to grow into a bigger industry. Alongside that, you've got to have the research. There's a lot of research to be done. We all know that new space regulations in place, and that's great. We know that there's similar programs around the world. But I think you'd be self-deceiving if you thought we'd cracked the problem. We haven't. There are very, very serious problems yet to be addressed, and that has to be done by research and demonstration, trying things out and growing and applying it so we can involve more and more stakeholders. So it's a long process that will involve all the stakeholders participating, but hopefully built on support by government and other bodies, just to try and have that seed corn to help things grow.
It is very interesting. You mentioned the sort of chicken and an egg conundrum. And of course, that's been a problem for emerging technologies since always, right? I mean, with manned aircraft, people were having to fly out of fields because we didn't have airports, right? And at some point that infrastructure had to be built. I wrote an article recently about skyports, putting together a very inexpensive modular system to try and just get those out there, use it for something else until it can be used for its intended purpose. So a lot of creativity going into that. Since you've talked about a lot of research needing to be done and how we sort of gather the data that's necessary to form that framework of regulations and expectations and common use, one of the things I'd like to hear, we talk a lot about in the US, Amit, and PK corridors. Are those sort of a viable option? We've got some of our test sites now, especially New York, developing those long-range drone corridors to test out different commercial use cases. Are corridors sort of an interim way forward for UAM? What do you think? PK, why don't you take that one first? Or sorry, Amit, didn't see you had your.
Yeah, certainly. So the New York state, originally we started that as a 50-mile UTM corridor outfitted with the right type of sensors and supporting infrastructure. As Robin was saying, it's a chicken and egg. And the goal out there was to start the infrastructure to enable these drone operations in a safe manner. Now it's just called 50-mile corridor instead of UTM corridor. But the idea is to allow businesses to experiment there with deliveries or search and rescue or highway traffic monitoring and such. And I think you are seeing that kind of a setup happening now in many other states. And I think Europe is also using that kind of a construct. They call it some slightly different model, but similar things are happening elsewhere in various parts of the globe as well. So I think that's just the way the infrastructure supported by either public funds or through companies and public-private partnerships together to get this industry going. So that's just one example. But I see that happening all over the place now. Slowly, you have 20-mile corridor, then you see that there is a business case and use cases that are flourishing, then you add more capacity to it. And eventually what ends up happening is then you say, oh, there will be first is one entrant, and there will be second operator and third operator. As soon as then you need a whole cooperative traffic management system. And at that point, corridors might be a good starting point, but it also has to integrate with the rest of the ecosystem in the sense that there is a flow management strategy that has to happen. What happens if the corridor is too busy? What happens when the weather actually impacts the entire corridor? Where do these operations have to go because there are other operations happening at the same time? So slowly you try to unleash the different layers of onion, and then you say, okay, I need to really figure out how do you integrate the entire system in place. So NASA actually has an initiative, and similar initiatives are happening in Cesar as well, we call Sky for All. The idea is to see how the future will actually be transformative and more adaptable rather than a fixed static corridor. So corridors is nothing but procedural operation. Those things happen in oceanic environment today. It's a more procedural operation. But beyond that, um, you may experiment inside corridor. You may allow self-management of the aircraft and things like that. But over a period of time, I think we need to be much more integrated than this kind of segregated things.
Amit, what do you think about drone corridors? Are they sort of
Yeah,
a reasonable next step?
No, so actually, I think I want to take a step back and make a distinction, because sometimes people say test site, test corridors, and people are trying to relate that to a UAM corridor. Those are two different things. When we talk about test sites and these test corridors, these are sandboxes. These are not necessarily the UAM corridor. When we say creating corridors in the UAM realm, it's like, hey, from Dallas downtown to Frisco, I'll create a UAM corridor. It's not necessarily a test site, but
It's more like a highway.
it's like a
More like a highway.
dedicated highway created. So those are two different things, because you can have all these test sites or sandboxes, but that's more for experimenting and testing the technology and the concept. They may not be necessarily viable business cases, because there aren't a whole lot of people waiting to call your eVTOL rights on demand to go from point A to point B. So I couldn't have said it better. PK said it all. Like the need for collaborative traffic management, because eventually, right now, we may start off with this segregation where we do some of this corridor stuff, but it's not a sustainable model long term. You need to have an integrated airspace management, collaborative airspace management, because some parts of the world, there's a lot of airspace. US is an exception. We have a lot of airspace. Now, if I go to Europe, it's a very dense airspace. If they all of a sudden we start creating these corridors and stuff, there won't be a place for others to operate in. So you have to eventually look at collaborative traffic management, which becomes the key.
So let me ask you this, because all three of you work very internationally. How different are the approaches in the US versus in Europe and in Asia? And is that okay? Or should we have more of a global approach to kind of get this industry going?
Shall I kick this one off? It actually follows on nicely from the previous question about corridors from my perspective. At first glance, it's very easy to see the differences between the different concepts. With a little bit of deeper study, however, you can realize it's sometimes a matter of perspective, emphasis, choice of words, but fundamentally, we agree in as many places as we disagree. Now, by global cooperation or coordination, I absolutely would be viciously against everyone doing things the same way. There are very good reasons why a different state may want a different approach. And Amit has just said one of them, that the airspace itself is different. And so it might need a different solution. That's okay. But we do need to coordinate at certain levels to try and reduce the disparity of solutions that might be provided to help providers produce to agreed standards and so on. That's got to be a good thing. But does it mean we all have to do things the same way? Then no. But I would add some caveats in here, a little bit of controversy maybe. I hear a lot of people saying that air traffic control's got nothing to do with this. Air traffic control can't do this. We need a new ATM type system, not even ATM, a new management system to do this. Well, that might be true, but I don't think it's a proven point yet. For example, the corridor philosophy of a pre-designed route for a different type of aircraft to use is already in use and has been for forever, for as long as there's been aviation. And so, you've got VFR routes, low-level IFR routes, you've got more modern, you've got point-in-space approaches, you've got PBN routes and so on. And so having a predefined route that a particular type of aircraft can follow is not a new concept. If you're going to put people on board these vehicles, which will be certified vehicles, then are the separation requirements going to be very different from a helicopter, for example? I don't know. We need to actually look at this. Separation minima and the technology to support it are as yet undefined. But the safety requirements of keeping that human alive are the same. So we shouldn't necessarily be particularly surprised if the requirements end up being linked. And the fact that we're trying to maneuver multiple airplanes and keep them separated could also mean that we shouldn't be surprised if there's kind of an air traffic-y feel to this. If you start looking, yeah, go ahead.
No, I just wanted to, I'm not disagreeing with Robin, but I want to make a finer point here, is because there are differences in different regulatory frameworks and how these things will get deployed. But the last thing we want to do is build these stovepipe black box solutions that are not interoperable. We have been there in the past. At the end of the day, like as industry, when industry builds systems, they are systems that can be deployed across different geographies. You don't want to build a system that is very specific to a country X in Europe and doesn't work in US. So you want to, that's why it's important. Remember I talked about those three circles: technology, standards, regulation. You have to find that standards becomes the key there, where you have standards where all these systems are used, all these systems implement these standards for building an interoperable system. But the way these systems get deployed and employed in a regulatory framework may be different based on the regulatory overlay of that. But the digital exchanges, the formats, message exchanges, those have to be standardized. I'm sure TK has a very strong opinion about that too, so I would love to hear his thoughts.
Yeah, I don't know what strong opinion. I think there are things that need to be standardized, like what's the safe operation look like? That has to be standard. What's the procedure for operating when your energy depletes? What happens when the birds strike? I mean, there are many things that will have to be harmonized and standardized, including what's the safe wind condition in which an aircraft can operate all over the world. That will be a same standard, right? So, however, there could be some subtle differences in terms of who operates the vertiport, and is it a third party that's providing services, or is it government corporation or such? So I think the business models and the business supporting structure might be slightly different. But one thing we can do is have completely chaos in terms of how these operations may look like from one country to another. Because in places like Europe and some parts of Asia, they will be transitioning between the countries, and you can't have one language. I mean, just ICAO decided that English is the language. Similarly, there will be some standard ways of operating these things. However, some business procedures and business rules, business physics, so to speak, might look different in different countries. But by and large, anything that has to do with safety, you will want to be standardized so that the experience that you have and assurance of operation will be harmonized across the globe.
So who do you think, or not who, but where in the world do you think that we will see sort of the first commercial operations, let's put it that way? So, I mean, we've seen, of course, there's commercial operations in Dubai, and we're saying, okay, Paris in 2024 and LA in 2028. But what region do you think will sort of get those regulations in place to have regularized services going first? Is it someplace that has maybe less air traffic, or what do you think? Any opinions?
I think it kind of depends on what you mean by services. I mean, if you're talking about air taxis and large EV tolls, being specific about that, okay, well, I mean, as you say, there are already work going on in Dubai. Let's not forget what Japan at the moment has got its Osaka 25, which is that they're looking at having some operations there. But if we're talking about full commercial operations, there is still a lot of regulatory and standardization activity to be done. We don't yet know how to certify these vehicles properly. There's a lot of work going on. There are different opinions on that. That will have to be sorted out. That will need ICAO agreement. And that work is going on. ICAO's got its new AAM study group going at the moment, which I have the honor to be part of. And this is actually, I think, precisely where we need to go. We need to have this global standardization work, as the other two speakers just spoke about. And until this happens, proper, regular, every day, if I might be like that, operations is going to be tricky. There will always be a case that someone has approved rather than routine operations. So where, I'll be honest with you, I'm not that interested. It's a question of let's get the standardization done, let's get the technology, let's get the certification worked out, and then it'll be everywhere.
I want to ask your opinions, all three of you, on another sort of chicken and an egg scenario. And that's when I hear that many of these VTOLs are being developed eventually for unmanned operation, but in the interim for manned operation. Okay, so that's sort of something that we understand better, is having the pilot as the last measure of safety, the pilot's brain and eyes and reaction times. On the other hand, unmanned operations has a whole nother set of benefits, because when you don't put a human in the cockpit, you don't necessarily put a human life in danger. So you have these whole other set of humanitarian benefits, which just can't be realized as long as they're manned. So chicken and an egg, do you see some of these vehicles being developed for unmanned operation right out of the box? How does UTM, how does that work differently for manned versus unmanned?
Yeah, so I'll go first. I'll kind of share my thoughts on this. So a lot of, I think the reason you're seeing a lot of push from these eVTOL manufacturers to have optionally piloted is to get airborne sooner. Because if it's piloted, they can fly under VFR or IFR rules and get the flights, claim the initial wins. But to Robin's point, that's not really a scalable model, because the goal, the return on investment is, if there are 4 seats in an eVTOL and you put 1 pilot in there, you can only take 3 passengers, right? So your return on investment cost to benefit analysis doesn't necessarily work out. But so that's something I think in the near term is just when, in terms of scale, I think it's going to be a while before it scales. And where you're doing, to Robin's earlier point, like have routine operations, and some of the, to touch on the point you made about airspace integration, UTM or PSU or U-space, when it's uncrewed, in the uncrewed space, obviously, like we talk about collaborative traffic management. So if you, depending on where you're operating, whether or not you need interaction with traditional ATC, whether you're in a control zone, controlled airspace or not, but there will be some digital exchanges between a UTM PSU / ATC, or in other cases, it may be just peer-to-peer deconfliction happening and tracking the traffic in a particular airspace. But now when all of a sudden you're introducing these optionally piloted vehicles, because there's a pilot on board, there are projects currently ongoing where there's testing of this concept, where you are having some level of traditional analog voice communications to communicate as you're ingressing, egressing out of controlled airspaces. So assume a situation where you take off from an airport, you go out into uncontrolled airspace, and then come back into the airport. Now, the pilot may be on board, or even if it's optionally piloted, that may be a digital call made from someone in an operations center, which is getting converted to a CTAF or a radio call and getting communicated across. So it's like a mix. It's like, what can we do right now to get going, to make some progress, not necessarily the final solution.
Anyone else want to comment on unmanned versus interim manned, and does that sort of slow us down or help us develop safety cases and use cases?
Well, I think it's an excellent question that needs to be addressed. I mean, the idea of having no pilots on board makes commercial sense, and it's a very exciting prospect even for airliners, dare I say. Look at these things and make they're possible. But, and there's a big but, when you start talking about pilotless vehicles, it's not just the ground technologies and communications, it's also things like decision making, AI, ML, this kind of thing in an aviation context is fearfully hard to certify, because you've really got to understand how that aircraft is making decisions and how it will behave in non-nominal situations. So there's going to be a huge resistance to having passengers being carried by an unpiloted vehicle for some time, until you can prove that not just the vehicle is safe and the AAM system itself is geared for this kind of thing, but also that the aircraft isn't going to go off and do a space odyssey on us and say, sorry, Dave, I can't do that. And we really do need to understand how to certify these complex pilotless operations before we can actually start doing it commercially. And I think that's going to be quite slow.
Because you can have piloted with passengers, unpiloted with passengers, but you could also say, okay, a good interim is unpiloted with cargo, right? No humans at all on board in that. And that sort of opens up different opportunities, because I think everybody's more comfortable letting something fly with no humans on board. Limits the damage. PK, what do you think?
Sure. No, that's a great question. And I think I'll just add slight variation to the very insightful comments that already Robin and Amit offered. But I think for autonomous aircraft and piloted aircraft, eVTOLs and urban air mobility and advanced air mobility, the MVP or the crawl, walk, run looks slightly different. So if you're autonomous going in directly, like WISC type operation in Merlin Labs and the Lab Robotics, then you would want to look at areas where you can actually use these operations in a somewhat protected manner, like wildland firefighting. So you have temporary flight restrictions, and you can actually fight fires, and you have basically preferred access to that airspace, and nobody else will be there except the operations that are fighting fire. So that's sort of like your crawl, walk, run approach looks like. That's the starting point for autonomous aircraft. That passengers likely before, so cargo likely before passengers is the path for these kind of autonomous vehicles. On the eVTOL, urban air mobility and advanced air mobility type operations, clearly their MVP and crawl, walk, run looks different. We're going to start with VFR, VMC conditions, clear weather, piloted operations, then go to IMC, then figure out if you can go to remotely operated, then figure out you can do M2M, which is many aircraft with fewer pilots, and then fully autonomous. So I think this minimum viable product strategy looks different for different types of operations. And a lot will depend on public acceptance and safety of these operations. And as we learn, I think Robin made that point before, that we need to learn from experimenting, we need to learn from actual flying these operations, and then figure out how to get past that. So the speed of going from one S curve or one epoch to another epoch, whether piloted to non-piloted, will really depend on what our learnings demonstrate that, and how quickly we can ensure the safety of operations and integrate with everything else.
Let me ask a question that sort of follows on to all of this discussion, because what I'm hearing is that there's not a sort of sequential, okay, it's step 1 to 275 and we just go step by step, and then we complete the process and we have, viable UAM throughout the globe. This is really a sort of complex structure that involves a lot of different elements. So with not talking about these outside test cases, they're part of the process, but when you think about how long it will be until we've established a framework of infrastructure, a framework of regulations, a hybrid a unified traffic control system, whatever that looks like, and so forth. Are we talking about 10 years? Are we talking about 20 years? Are we talking about longer? If you look at the development of the automotive industry, it was a very, very long time. Manned aircraft a little bit shorter. What are we talking about here? Our lifetime, our kids' lifetime? What do you think?
I think how long depends on what. So right now in Europe, we have a regulatory framework that's in place. So technically, a state can create a use-based system in accordance with this and fly today. Of course, it's not that simple. That would be very limited. It's segregated, which is not where we want to end up, but it is a start. So we can start now. Similarly, with a piloted eVTOL, once you've got the certification issues out of the way, there's not really any reason why it can't be operated exactly like a helicopter currently is, when there aren't so many of them, and maybe they can fly in and out of heliports and so on, just as an example. Again, that's not where we want to end up. So I think even for this kind of question, there is a crawl, walk, run. It's going to start with the easier targets, and slowly but surely evolve from there. Before we have them routinely in the big centers, I think we need to just not have a global, because it might never be global, but in the big centers where they're really pushing for this kind of thing, I don't know. I think it's certainly our lifetimes. I think we're talking about decades rather than half centuries. But I wouldn't say it's all going to be sorted in 5 years' time, for example.
Amit, PK, what do you think?
Go ahead, Amit, first.
So I think my answer would be very similar to Robin. I think we will see initial uptake and move towards commercialization in our lifetimes. So if you look at that, we're talking about the next 20, 25 years. I think we'll see that. However, long before that, I think we'll see pockets, regions, and areas where you'll see these operations take off. You already know, like, there'll be this novelty aspect of it and then real world application of it. So from a novelty aspect of it, and this was more a lighthearted conversation. I heard someone telling me they're looking at launching a eVTOL operation from the airport to the casino, and the eVTOL will have a slot machine on board as the eVTOL is going from the airport to the casino. So that's a novelty thing. Not everyone will go there, but like I believe we will see this will be more like a touristy thing, like a nice thing to do. So there will be those pockets. I think we'll see them in near to midterm, but real scale happening. I believe in the next 10 years we'll probably see some cargo and some limited scale passenger, and then maybe beyond that we'll move more into the passenger movement.
PK, what do you think? Decades,
I
centuries.
I don't think you ever want to ask a government employee how long it takes for anything. But I do think that the scalability will depend on infrastructure, manufacturability, setting up maintenance stations, the training for maintenance technicians, the supply chain. I think those things will matter along with their space integration. So not just the novelty, as Amit said, but you need to have an entire ecosystem to be in place to be able to scale these operations. It's critical that you are able to manufacture these at scale as well, and then maintain them. Every place that you will be operating and you want to operate reliably, you're going to need to have preventive maintenance capability. You need to have maintenance technicians, and they need to be trained. So there's a whole ecosystem that needs to be set up so that we can sustain these operations and continue and scale them in a routine manner. One and done is not the problem we are trying to solve. The problem we're trying to solve is how do we sustain them at scale, make sure that people will accept them, and the noise will be such that the communities won't find nuisance at scale. All these things will have to work together. So those are the hard, basically, factors that we had to play together. Once the novelty of these operations is over, then it becomes like, how do I make sure that the entire system is in place, life cycle, so to speak. And that's where the fun begins. And that's really the exciting part as to how do you make sure that the entire life cycle is set up right, that there are job opportunities for many, many, many folks, entrepreneurs as well, and see how we can benefit the entire society.
Okay, but You didn't give me a year's. See, government employee. How many
Let me
years,
give you,
Bill?
let me give you let me give you
I'm
a
the
decade for
journalist. I
scale.
gotta.
Yeah, yes, yes, yes. I'll give you a decade for scale operation. I mean, we started UTM in 2013, and we are still, 10 years out, and we are getting closer than ever, right? Absolutely, but still, I think it takes time. I mean, there's a lot of regulatory aspect. Again, one and done is not the issue. We see advanced air mobility, or if you can call it urban air mobility in Brazil and New York, Miami, a few places. There is already helicopter operations. But I think what we're talking about is this newer methods, electric propulsion and infrastructure for enabling electric aviation. I think that's very exciting and it's got a bright future. Certainly it's going to be about a decade or so for scaled operations.
Okay, great. I want to, we do have a question, and I'll get to that in just a minute, but I want to sort of bring it back to actually a very serious question, which both of you touched on. And this is the issue of kind of democratization. So it's one thing to have UAM going from the airport to the casino in Las Vegas. We see private helicopters. You go to Vegas, the private helicopters are going overhead all night long, okay, how do we ensure that this isn't just sort of rich person's toy? This isn't just sort of the cool thing just for rock stars, but that it actually has benefit for the majority of people, not the tiny minority. Is there a way to sort of build that concept of democratization into the process of developing these policies and systems?
I can start, Miriam. So I think unfortunately, there's no simple answer to it because there's so many elements of the solution. Like PK touched on it, the whole supply chain, the ecosystem, the maintenance, and the cost of these vehicles. Because right now, each of these aircraft costs multiple millions and millions of dollars. When you need a fleet of these aircrafts, you need to be able to produce at scale. The cost per unit needs to come down. Your operational costs need to be down. So unless that happens, I don't know if that will happen initially. So how do we prevent it from becoming a novelty thing? Things have to happen at scale. So I think that for things to happen at scale, certain use cases will preempt others, and those use cases will be where, because a lot of time anything that has a humanitarian aspect to it always wins, right? The cost doesn't become a factor in that case. So anything that saves lives and serves underprivileged communities. So that's why I feel like cargo and life-saving EMT kind of stuff, those applications will be, I think we'll see that's where, I don't know if democratization is the right term in this case, but as scale happens, as we start scaling these use cases, then other supplementary use cases will come into play where the cost over time will go down. It's going to be higher up there. Just like anything, when any new technology comes in, iPhone came in, it was pretty expensive. And then as more and more iPhones came out, the price came down, right? So it's going to be the same thing. It's going to start up high and then hopefully come down and plateau.
All right. Anybody else want to comment on that?
Yeah, I think Amit is 100% correct. I think the democratization, well, even now, you take an analogy, when you want to get from the railway station to your meeting venue in a big city these days, mostly the quickest way is a taxi. But not everyone takes the taxis all the time, and it's simply down to cost. They'll get in the metro, in the subway, because it's cheaper, and the mass transport on a cost basis is always going to be cheaper. So therefore, I think it's the same if you're talking about air taxis, is they're going to be limited by your ability to pay for them for some time. And in the early days, that's going to be a rich man's plaything, or businesses. I think there's really a way around that. However, we're all going to benefit from deliveries. We all get instant deliveries from things. And if you can create an ecosystem where vehicles can be used safely and effectively for mass deliveries, to speeding deliveries, then the technologies will develop for doing that can apply into the manned or the person carrying environment, and that will drive the cost down. So I think it's the scaling, it's the use of more mundane, if you like, less glamorous use cases that will ultimately help to pay for the nice shiny air taxis that we would like to see flying around.
All right. Let me get to the question from the audience. And of course, we have the absolutely perfect audience here to talk about that, which is how are Europe and the US collaborating on this? And so something you guys are very, very familiar with. Who wants to take this one? I know all three of you are working on it.
Well, I mean, I can start, and then Robin and I, obviously, besides being friends, we are on similar committees, and we collaborate significantly on ICAO. For example, ICAO has a U.S. advisory group where we both collaborate tightly on harmonizing at the global level. It's not just U.S. and Europe, but the rest of the globe as well. So we are certainly tightly coupled on making sure that the UTM and some of the framework pieces from the UTM are harmonized across the globe. ICAO also launched the Advanced Air Mobility Group, which has 3 work groups inside that. One is Vision, and one is Explore, which is the long term, and then also UTM. And Robin happens to be the UTM chair there, and I am the UTM chair on the other panel. So we are collaborating pretty well. We also have, through FAA means, there is a Eurocontrol and FAA collaborative work activities, and NASA supports FAA in those. So there is a significant level of collaboration that occurs, more than people usually think it is. In terms of certification, I know FAA, EAM, EAS are collaborating together. So a number of activities going on for the benefit of industry as well as general public. So, and we will continue to do that. We are on various committees together, and look forward to exchanging these ideas as well as studying and sharing lessons learned together. We just had a meeting 3 months ago maybe, where we shared lessons learned, deep lessons learned on UTM and the advanced air mobility related activities. Lots going on in terms of collaboration. More than, as I said, more than people probably think that goes on.
And
Yeah, thanks.
Miriam,
That
can
was
add
pretty-
to that. Sorry, go ahead, Robin.
So you first.
This is
Uh,
how
so
Europe and the US collaborate right here.
No, so I was going to say, I'll give you the first-hand our experience, because us as a technology provider, as an industry, and us operating in North America, Europe, and other parts of the world, many a times we act as catalysts, because we are actually one of the few companies that's actually doing airspace management for AAM in North America and Europe. Actually, I think we are the only one that has actually supported live flights, both in North America with NASA, FAA, as well as in Europe for CESAR projects. So we end up cross-pollinating, and I'm not saying we are the only means, industry is the only means, but industry does act as catalyst, because the projects have touch points, because the vendors bring the technology that was exercised here. Some things that were tried here didn't work well, so we don't try the same things here. Maybe we look at a different variation of that or a different aspect. And based on our experience, both sides have been very open to that cross-pollination. Robin, back to you.
Thanks, Amit. And it's been good to have you on board. There's some of our CESAR projects. In fact, just to build on the list that PK was talking about some big global initiatives, but even at a slightly more direct level, we have a memorandum of cooperation between the FAA, which includes NASA, and ourselves as the European Union. This particular agreement has created an action plan, a coordination plan that we use to bring the teams together to discuss in a formal way with the way things are evolving, and each party takes away lessons. We had a big delegation earlier this year to Washington, and there's a group from the FAA coming to Europe in the autumn. And so once again, we'll all get together. We'll be comparing notes, learning from each other, passing on experiences, and sharing. So the collaboration is vital, and we are making active steps to make it work.
I had another question come up from the audience that I wanted to get out there. We only have a couple more minutes before we end here. And that is when you talk about the implementations in Paris, in LA, in Osaka, are those sandbox operations or are they under actually a unified traffic management system?
I would say neither. The Paris ones, as far as I understand it, are talking about proper commercial operations, but they will be in airspace that is designated for the purpose and segregated, because the infrastructure and the system hasn't been invented yet to make it a proper collaborative environment. I think it's just too soon. There will be rules to allow other aircraft to come through and all this kind of thing, but it is essentially a segregated operation. I believe Osaka is the same, although they are having some fairly exciting people carrying vehicles across the harbor. But once again, I imagine it's going to be pretty much segregated. I'll find out more next week. So I'll be in Japan discussing exactly this. And so, but generally, I think simply because the infrastructure isn't in place, the operational environments are not yet written, the standardization isn't there, the certification isn't there. It can't be a proper collaborative environment until those questions are sorted out. That's my estimation. I don't know for sure about those initiatives.
So we are out of time now. In the last, just 1 minute here, I want to close this up. It's been such an honor to be part of this conversation with the three of you. But when you look forward to that 10-year, that 20-year time frame, what are you most excited for with UAM? How do you think it'll impact your personal everyday life? Amit, starting with you, what do you think?
I joke about this. I used to joke about this with my daughter, that like the day that will make me happy is like when I see my daughters coming to visit me and eVTOL and it landing in our backyard. That'll make my day. And we had a small part to play in that a decade back or a decade and a half back. That's what I really hope happens.
Robin, how about you?
Sadly, it's rather similar. I'm going to be long retired, and I'm very pleased. That's what I'm most looking forward to in that time period. But nevertheless, I would like to be able to look up in the sky, see this variety of exciting new vehicles flying safely together, knowing that I had a hand in making it happen. And it's a little bit selfish, but I have to say, there's a time when professional and personal ambition is rolled up with what you're trying to achieve. So that's it, I'm afraid.
That's great. How about you, PK?
I'll combine the two interests that Robin and Amit has. I want to make sure that Amit's daughter gets to his home in a safe manner with the UTM type system that we will build and that will support the scaling of operations. So my daughter will also come and visit me, and I will be able to go visit someplace. And when Robin visits San Francisco, then he can come and visit my home. But yeah, they're creating a scaled operation and a system that enables that in a safe manner, and the supply chain and the ecosystem. I think it's fascinating. Not too often in your own personal career you get to set up an entire structure for a totally new means of transportation, and this is exciting time.
All right. Well, I'm honored to have had the opportunity to meet with you all. Thank you very much. And thank you all for joining us here at the ANRA Huddle. Hope to see you at the next one.